Now we can also parameterize segments here of lines. And if we want to parameterize a segment from R0 to R1, we can write that as R of t. So the position at time t is 1 minus t times R0, which is your starting point, plus t times R1, which is your ending point. So this is a vector equation for the segment. Now notice here when t equals 0, we get 1 times R0 plus 0 times R1, so you're at the start. When t is equal to 1, the other end of our range here, we get 0 times R1 plus 1 times, 0 R2, 1 R1, so we're at the end. And if t was 1/2, we get 1/2 R0 plus 1/2 R1, we'd be right in the middle. So we've got your position vector R0 for the starting point and R1 for the ending point, and then we've got that segment in between. So as t goes from 0 to 1, R of t traverses that segment. So vector equation, also called a parameterization because t is a parameter. So let's go on and look at planes here. So we've looked at the constant planes, x constant, y constant, z constant, and those we're familiar with. So let's look at non-horizontal, non-vertical planes. So planes are determined here by a point and a normal or perpendicular vector. So lines, it's a point and a direction vector. Planes, it's a point and a normal vector. So let's say we're given a point P0, x0, y0, z0, and another point P, which is x, y, z, and a normal vector ABC. With that normal vector is perpendicular to P0P. So we've got a P0 right here, and let's say P is right here. And so P0P, that vector is going to look like that. And then our normal vector, n, is perpendicular there, so n is perpendicular here. And since n is perpendicular to P0P, that means if you take n and you dot it with the vector P0P, you get 0. And that's actually the vector equation of the plane. So if we take all the points P, where n is perpendicular to P0P, we get the plane. So that plane's going to look something like this. So P0P, that vector is down in the plane, and then this normal vector perpendicular is perpendicular to the plane. So the normal vector here is ABC, and the vector P0P is x minus x0, y minus y0, z minus z0. If you dot those, you should get 0 because they're perpendicular. Well, if you multiply out this dot product here, a times x minus x0, b times y minus y0, and c times z minus z0, set it equals 0, you get what's called the scalar equation of the plane. So that's right here. And that's the one that we'll use the most. So let's put this to use. Also, you'll sometimes see standard form for the equation of a plane, and that's where everything's on the left-hand side and 0 on the right. So when we find equations of planes, we'll more use the scalar equation. So here we want to find the equation of the plane that goes through the point 1, -2, 2, and with a normal vector 5, 2, 4, find intercepts and sketch that plane. Okay, well, let's bring down our scalar equation of the plane here. So we already know our ABC, 5, 2, 4. And then this is the point that the plane goes through. So that is our x0, y0, z0. That's a point that's on the plane. So we'll go ahead and put our 5, 2, 4 in here, and then it'll be x minus 1, and then y minus -2, so y plus 2, and then z minus 2. equals 0. So there's our scalar equation of the plane. We want to now find intercepts in Sketch. So let's go ahead and simplify this. So let's go ahead and multiply this out. So that'll be 5x minus 5 plus 2y plus 4. And then plus 4z minus 8 and equals 0. Let's go ahead and take all the numbers over on the right hand side. So 5x plus 2y plus 4z will equal negative 5 and positive 4 is negative 1 and negative 8 is negative 9. Bring it over on the right, positive 9. So now we can find intercepts, and that's how we'll sketch the equation of the plane. So we've got our z-axis here, and y here, and x here. And so our x-intercept, to do your x-intercept, you're going to set y equals z equals 0. And so if y and z are equal to 0, this will be 5x, 2 times 0, 4 times 0 equals 9. So it's just 5x equal 9. And so x is 9/5. For your y-intercept, that means x and z are equal to 0. So these two terms will drop out. We'll get 2y equals 9. So y equals 9/2. And then our z-intercept, we're going to set x and y equals 0. So these terms will drop out. 4z equals 9. And so z equals 9/4. So once you've got those three intercepts, 3 points determine a plane. So x is 9/5. Let's scale this off in ones here. So x is 9/5. 10/5 would be 2. So 9/5 would be, about right here. And then let's see, y is 9/2. That's 4.5. So it's going to be out a little farther here. Have to extend our y-axis and maybe change the scaling here a little. So 1, 2, 3, 4. So 4.5, about right here. And then our z-intercept 9/4. So that's a little bit more than 2. That's 2 1/4, about right there. And then we can join these guys up, and we can at least find the graph of the portion of the plane that's in the first octant. So when x, y, and z are all positive. So that's the graph that we can do.